Okay, I am just sharing the quiz. Just a minute. Give a minute. Just a minute, guys. I was lost somewhere. Yeah, here is the quiz. So join the quiz, like scan the QR on the screen and join the quiz. Yeah, fine. Like, let me wait for some more people to join the quiz and then I will start this. So attempt all the questions. There will be like total of 9 questions. And at the end, you will have a leaderboard and we will see like, can anyone answer all the 9 questions correct throughout the session. Scan the QR on the screen and join. Just wait for 2 more minutes. No, like some half minute for some people to come so that. And don't close this quiz tab. Like all the 9 questions will be coming on that particular tab only. So don't close. Whenever I say see that particular quiz tab, you just open that. So don't close it. Open, make sure that it is open throughout the session. Okay, I'm starting the first question. So you can even scan now and join the quiz, no problem. Like your name will be appeared and you will be there on the leaderboard. So try to answer this first question. Okay, these are the polls. Like I will just allow you. Yeah, I will just allow you to answer some more time. So fine, let's see the answer. So most sold to ensure data is transmitted with consistent timing between devices. So all of you are correct. Yeah, fine. So now answer this second question. Okay. Okay. Someone is stopping already. Wi-Fi, HTTPS, Bluetooth, etc. Who is this crazy name? Okay. So now answer this question. Let me give some more time to you. I hope you guys are answering the questions. So, okay, so 132 people have answered the question and 93% said device A. So yes, it is device A. So I will just clarify the questions for those who have answered wrong. Okay. So this is the question, right? The first question. So which of the following best describe the role of clock? What I told, like the clock will maintain the timing configuration and it will fix the frequency and thing, right? So option B seems to be correct. Let's read what are the other options. To encode data using various modulation techniques. So it is not something that I have taught even. To manage the network address or device. So it is also nothing to relate. To encrypt or decrypt data. It is also nothing to relate. Okay. So it's option 2 obvious. And then in a communication setup between two devices, device A and device B, the following actions between device A and device B, the following. Device A controls the timing and data exchange by sending periodic signals. Device B responds to the commands, which sends signals and which controls, like which will command. It is master, right? So device A is master and device B is responding. So it is slave. Okay. So that's it. So like we'll go back to the presentation once again. Just a minute. Yeah, here it is. Okay, we will move on. Okay, so now let's start. What are the protocols essentially? So that's what we were intended to learn, right? What is SPI? What is I2C first? So SPI is nothing but SPI features a single master and multiple slave sharing one MISO and one MOSI line. The MOSI line splits into individual connections for each slave. A distinct chip select line is assigned to each slave, limiting the number of connectable slaves. So this sounds like some complicated English. I will break down it to you. So it is nothing but like SPI is a communication protocol which is used to feature, like if there is one master and multiple slaves, we use this particular type of protocol. How does this work? So this mainly has 4 lines, like 3 lines mainly. One is clock, that is CSCK. So that is what I said, like clock must be there between 2 devices for communication. Another is MISO. The name itself suggests master in, slave out. That is master in. That is the master will get data inside. Slave out. That is slave will send the data. For suppose, and MOSI is master out slave. That is master will send out the data. Slave will get in the data. If for suppose there is a Arduino board and there is a microphone. So now if master want to send a command to microphone, say that microphone, you record the data. So what it will do? It will use MOSI line. Master out. From master onwards, the data will be out. Slave in. Slave will get the data. So it will send record. So okay, it will just record and it will store the data. And it needs to transfer the data back to master, right? Then it will use the second line, MISO. Master MISO. Master and slave out. That master will get the data as input, slave will send the data as output. Okay. So here it is fine. If you see the picture, there is this MOSI line. It is splitting into 3 more lines. And there is a MISO line. That like all the devices are sending output via one black line. And all those are meeting up and going into the master like this on the MOSI line. So now if master sends a command, then the command will be reaching to all the 3 slaves, right? So here don't worry about the names, think them as slave A, slave B, slave C. So all the 3 slaves will get the command. So if all the 3 slaves get the command, how does a particular slave know that that particular command came to me? For suppose there is a microphone, there are like 3 microphones considered. One microphone is at the stage, another microphone is at the audience, and some another microphone is somewhere else. So for suppose if the master need to send a signal, that is to the microphone on the stage to record the voice that what speaker is saying. So how do that particular microphone know that the data that it received is further? Because as the MOSI line is connected to all the 3 slaves, right? And how do that know? There comes chip select. So there are 3 lines of chip select. So for every slave, there will be a separate chip select line. If I want to communicate with the slave named ADC, what I will do is I will activate this particular chip select line and the remaining will be inactive. So when it receives some data, what that slave checks is whether the chip select is on or not. If the chip select is off, then it will decide, okay, the data that got is not for me, that is for some other slave. I don't need to worry. If the chip select is active, then it understands, oh, okay, this particular data that I received is for me, so I need to do that particular command. Okay, got it? Someone is raising hand. Yeah, what happened? Can you unmute? Hedikar, can you unmute? Fine. You might be raising hand accidentally. Okay, fine. I'm moving with the presentation. Okay. So what I was saying, yeah, the chip select line. If the chip select line is active, that particular slave will respond and do the command. So here I said the chip select is active low. Active low is nothing but generally what you would be thinking high. That is when the signal is 1, then that is active. When the signal is 0, that is inactive. That is not always fixed. It changes depending upon the condition. So if we say that the particular line is active low, it means that when the line is having 0 in it, it is active. If it is active high, when the line is having 1 in it, it is active high. So how do we determine whether it is active low or active high is by using a bar that is written above the line. If on that particular line, if there is a variable for that line and above that, if the bar is written, we say that that particular line is active low. If it is not written, we will say that it is active high. Okay, that is what chip select do. And there are some pros and cons of that. We will discuss it later detailedly. So the major advantage of disadvantage of SPI is, so if we have 3 masters, we need 3 chip select lines. But what suppose we have 100 slaves, like 1 master and 100 slaves. You might be thinking why I will have 100 slaves. That situation arises. It will arise because in practical applications, you will have hundreds of slaves and there will be single master. So your Arduino board won't be having 100 connections, right? So what will you do? So to overcome this, there is a configuration called daisy chain configuration. If time permits, I will explain it at the end. But just remember that this is a limitation. So you can't connect as many slaves as you want. Okay, this is what SPI. So we'll move on to I2C. So I am going to explain what is SPI and I2C first. Okay, so be patient. Like it is slightly more theory, but I'm trying to engage you as much as possible by giving questions and etc. Okay, so now I2C. So what is I2C? The full form of I2C is inter-integrated circuit. I said that in SPI, like if we have 100 slaves, so we need 100 lines. So it is a limitation. To overcome that, SPI I2C offers something better. So I2C only have 2 pins. Okay, only 2 pins. That is SDA, data line, and SCL, clock line. It will have only 2 pins for communication. So if it is having only 2 pins for communication, how does it communicate with multiple slaves? That's a question that arises. Here comes how the data is transferred in this. So SDA is a single data line. It is a 2-way data line. That is, master can send data to slaves. Slaves can send back data via that line to master. Okay. So I am just covering master to slave, how the data is transferred from master to slave now. So what master does is, first it will give a start bit. Okay. The data is transferred in a pack. Okay. Where it has one start bit and end bit at the end. Okay. So there will be a start bit at the first, and then after the start bit, there will be an address bit. What does this address bit do is, for suppose if you are having 100 slaves, it will give address to each slave. Slave 1 address is some XYZ, slave 2 address is 24, like slave 3 address is so and so, so and so, so and so. Every slave will have a fixed address. Variables names won't be random. For understanding purpose, I'm saying random, but they will have some fixed names. Okay. So for all the slaves will have different types of addresses. For suppose the particular the master want to now communicate with a slave, that is think about the same scenario that I had said before. So there is a master and there is one microphone on the stage. Another microphone is with audience. There are like 3 sets of audience, and team A has one microphone, team B has one microphone, team C has one microphone. So for suppose the master, that is a microcontroller, wants to activate microphone on the stage, then it will send the address of the microphone on the stage. So what each slave does is, when it starts receiving the data, first it evaluates the address. So the address that master had sent is matching to me or not. If the address matches to that particular slave, that particular slave activates. Okay, the data that is coming is for me, so I need to process that and do all the stuff. If the particular data is not coming, if it doesn't match, then it won't care. Okay, that's how the communication works. So now we no need to have different chip select lines. Okay, and that is the address itself will validate to which it needs to do. And after validation, I said that here it have only single line, that is for sending data from master to slave or receiving data from slave to master. It has only single line. So if it has only single line, how will it decide whether the data that if the sometimes the master needs to send the data. That is, it needs to send the command. Hey, you record the voice. Sometimes it needs to receive the data. Like it needs to say the slave, okay, you have recorded the voice, right? Send me the voice back to me. I will pre-process that. So here comes the read and write bit. There you need to send a bit. So if the bit is read, then we will say like read is equal to low. That is, if you send a low bit that is 0, then it says that okay, now it is in read mode. So the data will be read inside. If it is W, write mode, the data will be written. Okay, got it. So that's what like the read and write bit does. And then like there is a specific address to specific part of a slave. So you don't worry about what is this specific address to specific part of a slave. That is like if a slave is there, inside slave also there will be so many instruments, right? If you want to communicate to a sub instrument inside one particular slave, then you use it. So you don't worry about that. And then an acknowledgement. That is like after every 7 to 8 bits, we will send an acknowledgement bit so that like it will understand like, okay, the data is not broken somewhere. If it is not reaching getting acknowledgement bits, then the slave will think, okay, somewhere the data line is cut or something is happening. I'm not getting data properly. So it won't execute the operation. So that's the importance of acknowledgement bit. And after all this, like first start bit, then address, then read or write, then second address, that is address describing which part inside a particular slave you want to respond, and then acknowledgement bit. After all these are done, then the slave which you want to communicate, or else the slave part with the which part of the slave you wanted to communicate, it will be activated. Then you will transfer data to that. Okay. The final is data bit. After data bit is sent, it will send an acknowledgement that yeah, data is sent completed. And after the entire is completed, we will send an end bit at end. Or else if you want to like send some more extra information, you will give another start bit. So it sounds harder, like there are so many terms here, like what is the start, address, read and write, acknowledgement bit, second specific address, data, and end. There are so many terms. So you have not got all the terms, no need to worry all of them. Like no one cares, like no one remembers. But you need to understand like how I2C is working without chip select, right? It is working without chip select because you are sending the address at the start so that it is validating with the address, so that the need of chip select is not arising. So you need to catch that one particular point. Okay. So let's go for a quick quiz. So everyone please scan the QR. Wait a minute. I had stopped. Just a minute. I'll share 1 minute. There it is. Wait, it had gone somewhere. Yeah, I got it. Sorry, guys, like I had created a small disturbance. Yeah, I hope everyone is able to see that. And now if anyone had not scanned previously, do scan. If you have already scanned, then don't worry. This is the question. Now try to answer. It's slightly tricky question, but not too tricky, but answer it. I'll give you some time. Don't worry. I'm giving an extra 20 seconds. Try to solve. Still some 40 people have not answered, so I'm giving some more time to answer. Guys, I see an attendance of 200 people, 193 people, but only 160 people are active on the poll. So please scan the poll and answer the question so that you will be engaged. So still some 40 people are not active. So, okay, 76% people said SPI 6 pins, I2C required 2 pins, and 7 pins, 2 pins, 6 pins, 3 pins, and okay, the distribution. So let's see what's the correct answer. As majority said, 76%, but like so many people, like 25% people have confused. So let me clarify. So what's going on? So I said that there is a setup, there is one master and 3 slaves. So in SPI communication, what I said, like there needs to be a MOSI line, master in slave out line, and MISO line, master out slave in line. So 2 lines completed there, right? And third line is clock line. So there must be a clock line that connects to all the things. So clock line, 3 clock lines. So technically, like still we have 3 slaves, right? For each slave, we need to have 1 chip select, right? So plus 3 chip selects. So how many pins it became? 6. Now suppose if you're having 10 slaves, then you need to have 10 chip selects, 1 MISO, 1 MOSI, 1 clock. So total 13 pins. Okay. So that's for 10 slaves. For 3 slaves, it is 6 pins. And I2C, there is no, like, we no need to connect any specific pin to particular slave. We just need 2 pins that like all the slaves will be connected via that. Okay, got it. Okay. So I think like 76%, more than 100 people understood this thing clearly. So I'm just moving on to next question. Try to answer this. Do answer, guys. Still, I see a attendance of 200, but only 172 people are participating in the poll. So everyone do scan and answer the questions so that like you will get what's going on. Giving some more time you to people to think and answer. Like don't answer the one that majority people have put in. Okay, don't answer the question that the option that majority people have chosen. Like answer what you felt. Fine, like yeah, 92% had said, like I had already emphasized it, that like the sequence is like start the start bit and then address bit, then data transfer, then acknowledgement bit, then stop condition. These are the key things that you need to remember. There are like so many other bits like semi like address bit for specific part of a slave, and there are many acknowledgements there, etc. You just remember this brief structure. So this will be the final question of the first half of this session. Like there are still 4 more questions. Akshaya will deal about that. Answer this. Like guess, like you guess at least if you don't know. Just giving some more time so that like all the 174, like I expect like all the 200 people to answer, but only 174 people are on active. Like what the other 20 people are doing. Scan that, guys. Like there will be many questions coming later also. Okay, fine. I am showing the results. So, okay, 62% told that SPI is more costly than I2C, but it has higher data speed. And 15% told that it has lower data speed. The second is like SPI has the lower data speed, and third and fourth, like they're obviously wrong. Like by just seeing that SPI is less costly than I2C and has higher data speed. Like if cost is less, and like both can't be, like both can be true, but here it's wrong. So I'll just deal with the first 2 options. So the correct answer is SPI is more costly than I2C, but it has higher data transfer speed. So first thing, why it has higher data transfer speed? If you see, SPI has two lines. One is MOSI, master in slave out, and MISO, master out slaving. So it has two-way communication, right? It can communicate forward and backward simultaneously. Okay, like if, it can do the thing simultaneous. Whereas I2C has only one single bus. Okay, for both in like from transferring data from master to slave, and receiving data from slave to master. There is only single way. So what effectively happens? There will be some clash, right? Like it needs to wait for some time until the data is transferred, right? So naturally, only you can say that like I2C has a slightly lesser transfer speed than SPI. And SPI has more number of pins. It's not the only reason why SPI protocol slightly costs more, because it has more number of pins and etc. and all those things. So SPI don't think that cost is now only in terms of rupees. SPI, we need to connect so many chips, so many pins we need to keep, right? So we need to dedicate many pins to it. So you need to keep account of that. So when to choose IPI, when to choose when to choose what? That comes what next. So just close this, and in just 2-3 minutes, I'll start the simulation of I2C. So I will close the presentation in 2-3 minutes. So what are the primary differences between SPI and I2C? So SPI more cost. Don't think cost has only in terms of rupees. You think it in terms of equipment that you are providing to that. Like you are giving more chips to that, pins to that. So it might you can't attach any other things if all the pins were given to SPI. So more cost due to double way communication, which require more number of bits and pins, and less cost. But SPI has higher speed and I2C has lower speed. So the speed comparisons you can see here. Here it works on chip select. It works on 7 to 10 bit address. That is, SPI uses chip select to communicate, to select a particular slave. I2C does not work on chip select. It uses 7 or 10 bit addresses to communicate. Okay. So if you want high speed communication and if you are having lesser number of slaves, then you go for SPI. If you want no, I can compromise with some speed, but I had so many devices to be connected, then you go with I2C. So this, I'm not saying this is the final. So it is one type of sort you can decide to choose which communication protocol. Okay. So now let's go to a simulation. So I let us this just a minute. I will start sharing the simulation. So all of you guys open your Tinkercad, please. Just a minute, guys. I got some trouble in opening this. Just a minute. So everyone open Tinkercad. So just first drag two Arduino boards. Type the Arduino board here. Arduino, I am typing the spelling wrong. Yeah, Arduino. So you'll get the Arduino Uno R3. Drag two boards from here like this. Okay, two boards. And how to connect the push button was told to you in last session. So drag a push button from here again. So drag one push button and keep it such that when you drag this here, I had rotated it, right? How do you rotate a particular thing? So drag it and you select the thing and press key R on the keyboard. If you press key R, it will be rotated. So here it is 2A. So try to keep 2A only here. So now it is 1B here. Rotate one more time. So 1A here, rotate one more time. 2A. Okay. So you drag the push button and click on the R button to rotate. Such that you get 2A up here. Okay. Got it. Someone had asked, is clock not needed in I2C? Like I told, like there will be two lines. One is for clock, one is for data. Like the data is for input data and output data. We have only one single line. So in that one single line, both the operations occur. And the second one is for clock. Okay. So I hope everyone had came to this stage. If everyone came to this stage, just give a thumbs up. Like, is everyone able to? I got only one. Okay, I will wait for a few more minutes, like 1-2 minutes. Don't do late. So drag the push button and like connect ground. Keep a resistor here, connect a ground and connect it to 1A pin and here to 2A pin. Guys, if I'm going faster, then just drop in the comments. Like as I'm seeing in the polls, like in the questions where more than 100 people are answering questions correctly. So I am assuming that you guys are understanding properly. So I am moving slightly faster. If you didn't understand anywhere, just drop it on the question and answer section. Like I will just stop. So I hope everyone came to this stage. Bringing two Arduino boards here, getting a push button and making the push button such that the terminal 2A faces up. So when you drag the push button, press the button, like select the button and press the key R to rotate it. So you need to rotate 6 times, I guess, to come to here. So if you guys came to here, just give me a thumbs up so I can move forward. Hello, Sai Satvik, like I unmuted you. What's your doubt? Speak out if you can.
Yeah, could you please share the code for the Tinkercad?
This Tinkercad code. Okay, like I will share it later. So what you do is like currently just you move along with me.
All right, fine.
Yeah, so that like you will get the experience of how to drag this and connect this properly.
Okay, fine.
Yeah, that's why I'm waiting. So just drag to Arduino boards and connect this push button.
Okay, fine. Yeah, thank you.
Yeah. Yeah, you can speak, Ellen. Oh no, I think I misspelled your name.
Sir, using the wire, we are connecting the push button. Sir, from where is the wire there?
So wire, you can just like touch on that one cable and you can just drag like this. You'll get the wire.
What's the name, sir?
No, there is no any name. Like if you want a wire, wait, I will just say. If you want to connect this particular point to this particular point, first come to this point, then press on that point. You get like this coordinates. Then you drag it and attach to this. Okay.
Okay, sir.
Did you got it?
Yes, sir. Yes, sir. Thank you.
Yeah, fine. Mute yourself. Yeah. What's your doubt? Can you speak up?
Sir, I was having the doubt that to which terminal the push button is connected to the Arduino.
No, like I haven't connected the push button to anything. Like just I had dragged the push button and had connected the 5 volt to terminal 2A and ground to terminal 1A. Between ground and terminal 1A, I kept a 220 ohm resistor.
Okay, sir, got it.
Yeah. So if you don't know how to click resistance, like it was taught in previous class, just click on that thing and just type the resistance value. So I hope, like, I had waited so much time up to now. I think everyone got the connections up to here. So I'm moving with the next connections. So what next you need to do is, there is this pin right, terminal 1B. Connect this to any pin here, A0, A1, not any pin, either A0, A1 only. Like A4 and A5 are reserved. So I will say why they are reserved. So connect to A0 now. Okay, this pin 1B to A0. Okay, guys. After that, connect A4 of this Arduino board to A4 of the second Arduino board. I will say why you are connecting, but for now, just connect it blindly. So I'm just using yellow color line so that it will be distinguished that these two, like these two are for communication protocol. So like we have two lines, right? SDL and SD for clock and data. So those two, for the simulating that I2C environment. So I'm taking two lines and connecting like this. That is connect A4 of one Arduino board to A4 of another Arduino board. Some of you might be feeling that I'm moving slowly, but like instead of moving fastly and saying like not getting you everything done, I'm saying it slowly so that you'd be getting something out of the session. So when you have connected the A4 and the A5 of first Arduino board to second Arduino board, then connect ground of first Arduino board to ground of second Arduino board. This is called as common grounding. Okay. Okay, I hope you have connected this, and then when you have connected A4 of first Arduino board to A4 of second Arduino board and A5 of first Arduino board to A5 of second Arduino board and ground of first Arduino board to ground of second Arduino board, then you need to connect an LED to second Arduino board. So first search for resistor. Okay, here is resistor. So I'm just connecting the resistor to ground. Okay, and then I will bring an LED and connect it here. Always make sure that cathode is connected to the ground. Okay. And then I have anode. I'm connecting the anode to 13 volt. And try to follow the color code. Like in smaller circuits, you won't have any problem with the color code. But when the circuits become larger, if you don't have color code, you will be confused. So this is the setup, what we need to do. If everyone had came up to here, then just just signify like someone is raising hand like this. Yeah, Samir, tell.
Sir, why didn't have to give power to LED when only we put in?
I didn't got you. Can you say again?
Means only we connect the LED to the digital pin board and not to the power. Why, sir?
I am connecting LED to the 13th pin. Yeah. Why are you asking why I had connected to 13th pin only?
Yes, sir. But why didn't we give from power means?
Okay,
Why didn't we give?
why are we giving power to the LED and connecting that to the Arduino board? You are asking, right?
Yes, sir.
Yeah, like what happens here is, for suppose if I press the push button here, later I will write in the code. If I press the push button here, this is the data transferred to this Arduino board will be 1. Okay. When 1 is transferred, that is outputted via this cable 13. Okay. When 1 is here and 0 is here, so here it is 0 volt and here it is 1. 1 means 5 volt. Then the LED will glow, right?
Yes.
Okay. Okay, so what we are essentially doing via this setup is I'm going to declare this as master and this as slave. Okay, so what I will do is when I press the push button in the master, the LED in the slave must glow. That's what this small project does. Okay, so if I press the push button in the master, the LED in the slave should glow. Okay. And Samir, are you having still any doubt? If yes, unmute and speak, or else down the hand.
Sir, can't we do it in one Arduino board only? Means which we have to
I
join
didn't
two
understand.
boards. Can't.
Yeah, now I am using 2 boards. So one Arduino board is acting as master and the second one is acting as slave.
Oh, yes, sir. Yes. Understood.
Okay. Is it clarified? Yeah, fine. Got it.
Yes, sir.
Okay, guys, like I hope everyone was clear. Okay, someone else is raising hand. So yeah, speak out. Guys, are you raising hand? Like, is my voice audible? Or else, like, is there an issue? Type it on question and answers box.
Sir, can you please explain the master Arduino again, the connection of master Arduino?
So the master Arduino, we had like have a 5 volt and we have a ground and we have a push button. Like we have just connected the 5 volt to terminal 2A and ground to this terminal 1A. And we are like when we press the push button, that data should be transferred to A0, like some pin, right? So I'm using this terminal 1B and transferring the data to A0. This is what the push button does. Okay. And after that,
Yes, sir.
I am connecting ground of slave master to ground of slave. That is, I'm commoning the ground. So both have same ground. Like for suppose if one has 0 and another has 0.2, it might not cause problems in this circuit, but in future circuits it might cause when the circuits become bigger. So it's a good habit to have a common ground. And then we are like connecting A4 to A4 of slave, A5 to A5 of slave. So why I am connecting them, why they are fixed, I will explain them during the. Did you get it?
Yes, sir. Sir, here A0 and A5, A4, these are the data transmission line.
Yeah, A4 is for clock and A5 is for data, serial data line.
Okay, sir. Thank you.
So for I2C communication, they are fixed. You'll get more clarity why I am fixing that when I am writing the code. Did you got clarification? The ECE 191 something. Can you speak? Okay. Okay, I guess you're not having any doubt. So fine. Then I am moving to the code. I hope everyone was done with the setup of the Arduino boards and push buttons and everything. So now let's start move into the code. So okay. So here I have two Arduino boards. So one is this is Arduino board 1 and this is Arduino board 2. Arduino board 1 is master. Okay. So what I need to do is I need to include one library. So that is hashtag include capital W. Note, like if you keep small w, that's it, the code collapses and you can't identify it. Like it caused many problems to me many times. So hashtag include wipe.h. So I'm including that library. Okay. So what does that library do is that library is what which gives the I2C, like the I2C communication protocol. In that library, all the functions regarding I2C were there. Why we have connected particular terminals of particular pins in Arduino. I will explain that in the code. I will explain you. I will get to you. Why to common ground? I had explained it already. Okay. So that is hashtag include wire.h. That library has the functions which are used for I2C communication. Okay. And once you are done with that, we will declare the remaining things. So I have a push button here, right? I'm declaring push button. So int push button equal to A0. So I'm declaring that the A0 pin as push button. So like in future, whenever like I want to write, I do like writing A0 doesn't make sense. Writing push button will make sense. So I'm writing it as int push button equal to A0. Then I'm declaring a temporary variable x equal to 0. What is the role of this temporary variable is that it stores the data. So if I press the push button, then like it should store 1. If I'm not pressing, it should store 0, right? I need to store it somewhere, right? So I am using a temporary variable and I'm initializing that to 0. I hope it is clear up to now here. So now let's jump on to setup. So what are the things that I need to set up? So first, what I need to do is I need to initialize a function called wire.begin. So this answers the question why I had connected particular pins of master to particular pins of slave. So when I write wire.begin, what it does is it automatically initiates I2C protocol. Okay. So if I write the wire.begin command, the Arduino board will understand, okay, now, okay, I need to communicate in I2C protocol. When it knows that it needs to communicate in I2C protocol, it will make sure that A4 generates the clock and A5 will be transferring the data. Okay. And here there are two commands like wire.begin, and if you don't pass any argument in that, by default you are saying that this Arduino board is master. If you pass any argument, like if you pass some number 1 or 12 or like some number, you are saying that it is the Arduino that is like the slave number of Arduino board. If you write wire.begin of 1, you are saying that okay, this Arduino board is slave number 1. Like if you don't pass any command here, if you don't pass any number or any letter, then if you just write wire.begin, you are saying that this Arduino board is master. Did you got it? How to declare a particular Arduino board as master or slave? Okay, so I had written the wire dot begin. So now I will go to the next. So that is next. I am declaring the pin mode. So what is pin mode? So A0 is where I'm taking input, right? So I need to declare it as input pin, right? So push button. I had already written A0 as push button. So pin mode push button as input. So I'm declaring push button as input. So this is the setup that I need to do for this thing. Okay. So that's what I had done. I had written void setup. So now let's go on to void loop. So if I need to start transmission, I need to like begin the transmission, right? So write void dot begin transmission, to which I need to transmit to slave number 1. So I will declare this as slave number 1 in the code of Arduino 2. So here it is there, right? So this is the code of slave. I had not written anything. Here I will declare the Arduino 2 as slave number 1. So here I need to mention to which slave I am transferring data. So wire dot begin transmission of 1. Okay. That's how it works. So I am beginning the transmission. Then after you begin the transmission, what you need to do first? First, you need to read what what the push button is saying. So digital read push button. So it will read the data of the push button, like what the push button is sending. After you read, what you need to do, you need to write it. So you need to write it to slave. So wire dot write. Make sure like in wire W is capital, in write W is small. Wire dot write of X. Okay, you have written the data. After you have written the data, you need to like stop the transmission. So end transmission. That is, I'm ending the transmission. So like, and after every set of code, have some delay statement. The use like why you should have is you can't press the push button infinite times, right? So I'm giving a delay of 500 milliseconds. That is half second. So that like every half second, I will be taking the data once. Okay. Is everyone having clarity up to this point? Yes, speak out.
Sir, why we don't have any argument in the void setup while we're writing wire dot begin?
Which argument do you mean? Okay, inside this.
Yes, sir.
Like we no need to have like require any argument, right? So in void setup, like inside that like setup itself, we are written and inside we are describing. So this like wire dot begin takes care that A4 is for clock, A5 is for transferring data, and that pin mode will describe that this particular pin is that particular pin. So we no need to send any arguments, right? Any argument is not even required now. Why is delay at the end needed? So why do we need delay at the end is like, for suppose if you don't have delay and if you pressed the push button, it recorded 1 and you have removed the push button. If there is no delay, like it natural, like the equipment will have some slight delay, right? So for suppose it is having some 40 or 50, like some 100 nanoseconds delay. And if you just press the button and remove, and if there is no delay, when you have removed, it will read it as 0. You pressed and you removed, right? Immediately after your removal, the data will be read as 0. So never the LED glows, okay? Because like you can't record data with infinite resolution, no. So you can just record with some finite resolution. Like you can press only half a second once, or 1 time a second, or 10 times a second. So you have some limit. So at what maximum rate can you keep on pressing that? So that we need to have some delay, okay? What does wire dot begin do? I already told like void dot begin will make sure that A4 will be for clock and A5 will be acting as a serial data line, and it makes sure that the data is transmitted. So in I2C, I had said that the data must be transmitted in a specific format. So first there must be a start bit, then there must be address bit, then there must be some second address bit, then there must be data. In between there must be some acknowledgements and so many things. So all this format is taken care by the void dot begin. Okay. Yeah, that's it. The questions there. So everyone is clear with that. So yeah, I'm moving to next. So now let's move on to second Arduino. That is slave. So now let's move on to the slave. Okay. So in slave also, like first what we need to do, we need to include the library. Include capital W wire dot H. Okay, I had included the library. And then where is the pin that is? Okay, pin number 13. So pin number 13 is LED. So I'm declaring int LED pin equal to 13. Okay. And then I need a temporary variable to store the data that I receive. So slave receives the data and it also needs to store the data somewhere, right? So write a temporary variable int x equal to 0. So that's here. And now let's go on to the setup. In setup, what we will be doing, first we need to write void.begin command. Void.begin. So if I just write void.begin, what the Arduino board will assume itself as master. So we need to write an argument inside 1. So that is, I am declaring this particular as slave number 1. Okay. So that's what void.begin1 command does. And then void.onReceive. The name itself says void.onReceive. That is, when the data is received, receive event, that is execute this particular function. So I will define that particular function down. This is not something inbuilt. That is something that I define. So you can like replace this name with some ABC or something also. But I'm just saying that this is something that we defined. Okay. So first void.onReceive. So whenever we receive the data, we need to execute this particular function. Got it? Yeah. Okay. Fine. So that's what we do. We will define on receive later. I will receive, and then I need to still have some more pins, right? I need to declare LED pin as output. So pin mode, it's LED. It's a spelling mistake. So it will cause problems. Pin mode, LED pin, comma output. Okay. So I'm declaring LED pin as output. Okay. So that's what void setup I completed. And then here we will come to void receive event. So in void receive event, there is an argument int how many. So where did I pass this how many? So I won't declare this how many explicitly, like I won't assign that how many some variable or some number. So I2C, so void.begin I had written that. So I2C had already started. So that internally takes care. So how many, it just represents number of bytes of data that I got input. You don't need to specify number of bytes of data that you got input. You just like need to like specify how many by like it inbuiltly specifies like how many bytes of data it got. That's what the variable how many does. So you don't need to worry about that thing any bit. So we will start writing. So I had declared the variable x equal to 0. Now I want to like read. So whenever I receive data, what I need to do first? first thing I need to do is I need to read the data. So wire dot read. So I'm reading the data first. So wire dot read. After reading the data, what I need to do? I need to compare. So if x equal to 1, that is if I had pressed the push button, then what I need to do? I need to glow the LED. So I need to say the LED to glow. So what I need to do? Digital write. So in digital write, W is capital. Be careful. Digital write pin mode high. Oh, sorry, digital write LED pin. I mean LED pin high. Okay. If it is not the case, else what you need to do? You need to write that is if x is not equal to 1, what it is? It must be 0, right? So you will write digital write LED pin low. Make sure not to make any spelling mistakes. Okay, this is the code. So I'll wait for few seconds so that you all people would be able to write the code. So write it first. Yeah, one more thing. Yeah, sorry, I forgot this. In void loop, like I need to declare some delay of 100 milliseconds. So because it can't process anything that fast. So anything like won't happen instantaneously, right? So we need to give it some time, some 0.1 second so that it will process like, okay, it will just process the data. So I need to give some delay, like after every operation, there must be some delay. Okay. So I had declared that. Is everyone clear? So fine, let's just see the code once again. So this is code of our Arduino board 1, that is the master. And this is for the slave. So you'll start simulation. We might get errors, but be patient. So even though we get errors, we need to like look after where we got the errors. Oh, fine, great. So it worked well. So now I am just pushing this press button. So when I press the push button, you are seeing the LED is glowing. If you see, I pushed LED glowed. LED glowed. So for this, if you want to press the push button, just tap on the push button once. Is it clear? Did everyone reach to this stage, or else if you are having any doubts, raise hand or post on the question and answer section. Some, yeah, I mean, oh, okay. Get down your hand. Yeah. Oh. Yes, peak. I got error invalid header file. So when you got error invalid header file, it means that you have made most probably, if you had followed the same, you might have made some spelling mistakes somewhere. So you don't worry and like don't try to debug that, try to debug and don't waste too much time. We will share the code with you, then you can verify. Most probably it will be due to some error. It's showing me invalid header file. Yeah, like if it is showing you invalid header file, that's the problem. Please show the code again. Okay, I'm showing it again. I'll just share the code on chat box. Just a minute. So yeah, I had shared the link of the entire code, that entire push button, LED push button. So you can just open it and simulate it, but you can just open it and go through it. Yeah, Jawahar Prakash, can you speak?
It is better to give some delay in the LED high, right? LED high, right? Otherwise, it will immediately switch off.
Okay, you are saying to give some
The
delay when the
code
LED is high.
Yeah.
Yeah, you can give, but like because you no need to give it, because I will say the reason. So x equal to 1 you got, right? So LED is glown. So for the next time data comes, when will the data come inside again? After half second, right? Like up to half second, if you even press the LED how many times, the data is not taken, right? Like the push button. For suppose if there is a, like in half second, it takes data once. So if you even press that for 10 times also, it won't take data 10 times, right?
Okay.
Did you got my point? So like in half second, it takes data only once. So if you press the push button, it will take the data as 1. So it will have the data 1. Okay.
Okay.
So we no need to like worry about that. So for that entire half second, the LED will be on only.
Okay.
Yeah. Okay. No response from LED while the code has no error. So if the code has no error but no response from the LED, like make sure that the connections are correct. Like sometimes you might have just kept the connection somewhere nearer or something. So most of the time when you click the push button, the LED glows, but sometimes on pushing it, it doesn't glow. No. Why it doesn't glow is like if you push the push button like 2 times, like tap 2 times, it won't glow. Like if you just tap 1 time, it will definitely glow. I'll just show you once again. So keep on the push button and tap only 1 time. Wait, where am I? So wait, sorry, I'm not there. Yeah, here I am. Yeah. I'm just tapping, see. If I tap 1 time, it glows. If I tap 1 time, it glows. Okay. Okay. Okay, then that's it. Like I will share the code of this, and if time permits, we will discuss about daisy chain configuration at the end. Like we will start UART and Wi-Fi protocols. I will hand over the session to Akshay. Wait, some, yeah. Akshaya?
Yeah, hello. 1 minute, guys. I'll share my screen. Is the screen visible, guys? Like, just react if it is. Okay, that's good. And you guys are able to see it. So hi guys, this is Akshaya, and I'm going to be talking about UART and Wi-Fi protocols. So we'll start in a second. Yeah. So basically UART, like if you just expand it, it stands for Universal Asynchronous Receiver Transmitter. You might be wondering, right, what all these terms are. We are going to explain everything, don't worry. So basically what this protocol does is that it's just between, sending serial data between two devices. And if you look at the connection, right, like I've shown it here. Let's say there are two devices, device 1 and device 2. And there is an RX pin, TX pin, and a ground pin in all these devices. So RX is the pin which will receive data. TX is the pin which is going to transmit or send the data. And there is this ground pin. There is a common ground kind of, connection between the two. So the RX and TX of each of these devices are connected to the other for successful transmission of data. And basically, when we're talking about data, right, data can be sent in multiple formats in UART. One is simplex format, like, only in one direction the data is sent. Other is half duplex, like duplex itself you can understand, right? So there is something related to a 2. So both sides data communication is occurring. And half duplex is like one communicates at a time, the other waits, and then the other communicates. Whereas full duplex is like there is a simultaneous transmission of data between both the sides. So as I already told, UART is there is some asynchronous term which is mentioned. So what does asynchronous tell is that there is no inbuilt clock to synchronize the data between the two devices. Like there was a clock pin, right? For I2C and UART for like I2C and SPI, there is nothing like that here. So there is no clock. So how is data transmission done? That is a question, right? Because if only the two devices are synchronized properly, will proper data be able to be sent and received? So what is done is that initially, in the beginning itself, these devices, they agree on some common baud rate. Baud rate, as you guys already know, it is the rate at which data is sent per second. So like we'll talk about the working a bit later. I'll introduce a few more terms to you guys. And with that, we'll start with the working. So you can see the diagram which I've mentioned here. Right, so there's something called idle, start, data bit, stop, and all of these. So idle state is when there is no transmission which is occurring. So generally when you're starting something or switching on something, everything goes from low to high. But in this communication, it goes from high to low. That is when there is some start bit which is sent. It's like a transition from a high state to a low state. Now, what is high state? What is low state? I guess you guys will get a better clarity in the digital design segment. But you can assume it is like some digital, like there is some logical 1 and logical 0, like on and off kind of thing. And that's like high voltage and low voltage level. That's it. So start bit is like some starting. It marks the starting of some data transmission. And stop bit obviously tells that there is some stoppage in the data which is going to occur. And you might be wondering, what are the data bits? So data bits are the useful information which is sent between the two devices, and their length is kind of variable. It can be like 5 to 9 data bits, but most commonly it is 7 to 8 bits. And besides the start, stop, and data bits, there is some additional bit called as parity bit. This is generally not mandatory. This is not mandatory at all and not even used. But I'm just telling you guys what it is. So parity bit is like some measure for, measuring the correctness of the data received. Like, let's say like any data that will be in the form of zeros and ones, right? That's how the computers or any device is going to understand. So that's the data bits which will be sent. Now, there is some odd parity, even parity, and mark parity bit. So odd parity means that if the number of ones, that is in the useful bit, if the number of ones is even, then the parity bit is set to 1, otherwise 0. And vice versa for the even parity case. And mark parity means that the check bit is always 1. So how is this parity used for, where is it used? It's used for error correction. And we'll be talking about that once you guys know about how this works. So we'll start with the working of UART. So basically, it's like two people are communicating with one another. And let's assume a simplest communication method. That is, one person is sending data, the other person is receiving data. So it's kind of, easy to visualize and understand. So there is initially some kind of agreement between these two devices. It's like, they will decide on the baud rate. As I told, there is no clock signal, right? So they will decide upon a common baud rate. What is the start bit? What is the stop bit? What is the length of the data which is being sent? All of that. And with that, now let's call the first device the sender and the second device the receiver. So sender is sending data, receiver is receiving the data. As simple as that. Now the sender will send a start bit. So why is this start bit essential is because initially there is no clock, right? And the initial baud rate they will decide, and now the second device, the receiver, what it will do is it will adjust its clock to receive the incoming data. So that is what is happening with the start bit. And whatever data bit, whatever is the useful information, it is being sent in the form of data bit. And if there is some additional parity bit, if it is required, then that will also be sent. And then the stop bit is sent, and finally some processing is happening with the received data. So this is as simple as that. So there are only these 5 steps, and these go on a repeat, right? So where all can errors possibly come in such a simple means of communication, right? So there could be some transmission errors, some corruption could happen, which are called as framing errors, or some overrun issue can happen. Basically, like if you take a computer, its CPU will need time for processing the data, right? The same thing happens here also. It's like before the central device is able to process the data, another byte has arrived. It's like before, like, how do I say that? If I'm giving you 5 words in the beginning, and before you guys can even understand what I'm trying to tell, I'm pushing in the next bit of data. There is some conflict, right? The same kind of thing is called an overrun error. Before the byte of data in the memory is read, another data is sent. This is kind of the most common error which will happen. And there is another error, parity error. As I told you, parity is what? It will just check the number of ones and zeros, and accordingly it will send them out. If suppose some data bit got corrupted or something or the other happened, right? There will be a parity error for sure, right? Like, are you guys clear with this part, or is there any doubts so far? Like, do you guys not follow anything, or is there any doubts? Okay, you guys are understanding. Nice. Any Q&A, any questions? No. Okay, so you guys are clear with this. Nice. So we'll talk about where UART is going to be used. Where is UART used? It's like used for microcontrollers communication with other devices like sensors. Right, so it's kind of the most basic communication which is kind of used. And it's also used for connecting computers with other peripherals like printers, scanners, external devices and all. And it's used in GPS modules and also as a communication interface between microcontrollers and wireless modules. It's kind of like some subdivision itself. That's what it is. But thing is, since this is very similar, very simple communication protocol, it has its own pros and cons. And pros being that it's very simple, very easy to configure physically, and error detection is kind of very possible. But there are a lot of cons. The thing is, it has a relatively lesser speed when it's compared to SPI and I2C. It requires higher power consumption. And as I told, data overrun issue is very common. And this is asynchronous communication, right? So there is like some proper configuration from both the devices is required. Otherwise, a lot of data loss and mishap is possible. And it's not very efficient when you do it for multiple devices. Because, as you had seen in SPI or I2C, right, there is no built-in addressing mechanism. It's not like, one particular information can be sent to one device and the other to another device. That's not possible. So that is the biggest kind of con which is associated with UART. So yeah, with that, we come to an end of UART protocol and we'll start Wi-Fi. But Wi-Fi is something everybody knows, right? So what do you guys know about Wi-Fi? Just comment it. Like, I want to see what you guys know about Wi-Fi. It's kind of very common. Whatever comes to your mind, you guys can answer. I just want to see some chats, some answers. You can expand what is Wi-Fi, where is it used, what do you know about that protocol, anything. No answers so far. A connecting module, yes. More answers, people, come on, I need more answers. Wireless fidelity, nice. The expansion, yeah. Like, where do you think this will come in use? Like, this function is actually present in some development boards. So where do you think this can be possibly used? Or in generic answer also is fine. Come on, people, answer. Wireless communication, yeah. It is a serial communication protocol which is used in data transmission, yeah. Data from other devices wirelessly, true. Wireless communication, yeah. So yeah, you guys do know pretty much well where this is kind of used. So I'll come back here and I'll present a minute here. So before we go on to Wi-Fi, right? There is this short quiz which is there. So you guys can scan this QR and go to the Slido page. We'll be starting another short quiz now. There are just 2 questions, guys. Not much, actually. Just a minute. So yeah, you guys can start with what is UART? What does it stand for? Just the abbreviation would do, guys. Only 53 people have voted. Can we go back again another 20 seconds? I'll give you guys. 181 people are there. People, only 57 have voted so far. Is it so confusing? Yeah, 97 people have 97% have voted properly. It's Universal Asynchronous Receiver Transmitter. That's what US stands for. All the others are kind of wrong because of one or the other words. We'll go to the next question. Guys, even now you guys can join the Slido quiz. This is a very simple question, people. Come on. Is setting parity bit mandatory for UART protocol? Oh, yes and no, 50-50%. Okay, we'll break that 50-50. Come on, people. Hundred and 3 people voted. Okay, 54% people have said yes, and 46 says no. Actually, it's no. You guys don't need this thing. Parity, but as I told, it's not mandatory. It is sometimes set. You see the leaderboard now. Saurabh has got all 7 right. Nagarjun, Ashley, Satyam Kumar. Great people, you still have time. We'll still have more questions. So before that, we'll come to Wi-Fi protocol. Right, another very simple protocol. So what is this? This is a wireless means of communication or exchange of data between two devices, right? And the most important thing for setting up Wi-Fi is, of course, the internet. So I've put this picture here, as you guys can see. It's like the internet is kind of the tracks, and the railway, the engine and everything is kind of the Wi-Fi and all the devices which are mounted. So internet is kind of the basic thing for a requirement for Wi-Fi. And so how is Wi-Fi communication protocol activated, or how is data transmission done? It's basically through radio waves. What happens is, let's say a router is first connected to the internet and it is taking data from the internet and it's converting it to radio signals and sending it to different devices. And at the device, this radio waves are decoded to get meaningful information, and whatever task or whatever has to be done is done, and is once again sent back as radio signals to the router and vice versa. This is how the communication is basically done. And so you guys would ask, like, why is a Wi-Fi protocol important for any development board or microcontroller? The thing is, it has a lot of applications. Like some Wi-Fi, like some applications are like some communication between two microcontrollers, or some weather monitoring protocols, or some IoT based applications. Like for example, you say there is a you're measuring the level of water in some tank, and you want that to be communicated, like each instant what is the water level in the tank or something like that you want to measure. And that's where this Wi-Fi protocol is going to be used. So before that, the thing is, Arduino does not support Wi-Fi protocols. So you guys will have to use another development board called ESP32. The only difference is that, it's some Wi-Fi and Bluetooth enabled thing, and it kind of looks a bit different. That is basically the only difference between these two boards. Otherwise, they are kind of one and the same, right? And the platform which we're going to use is Walkme. So you guys will have to log into Walkme now. I'll be doing that 1 minute. So I'm opening a new window. Wait, that's not getting shared. 1 minute, I'll reshare that. Hope it is visible, guys. Yeah, so just type walkme.con. Done. And the first website which it's going to take is the website which you guys need to go to. And it opens this. So here you need to sign up or sign in. Like, it's kind of important because you'll have to save your work, right? So same kind of thing, what you use for Tinkercad, the same thing you can use here. So go type in your email and create your account. Just type it here. Let's say email I'm giving, and go log into your S-mail or whatever mail you have given, and go log in, and you're just introduced to Walkme. Done. So once you guys are done, just react to that so that we'll be able to go forward. Any doubts you guys can also ask. Yeah, there's a more. So are you guys done logging into Walkme? Just react, people, if you guys are done. Okay, so we'll start with the simulation for Wi-Fi now. 1 minute, I will share my screen again. So once you guys are logged in, it will take you to this home page of Walkme. So this is the page you guys will be facing right now. and click this icon on the right corner and go to My Projects. And in this, go click a new project. And the first thing you'll see is the ESP32 board. This first board is the one which we are going to be using here. You can see, right, integrated with Wi-Fi and Bluetooth connectivity. That's kind of the biggest thing which ESP32 is used for. You can go and choose Arduino beginner template. And then you should be in this screen, right? Hope you guys are able to do so much so far. Is it clear, people, or is there any doubts like, logging into Walkthrough or something? You want me to repeat any of the steps? So you guys are clear with this, I guess? Then we'll start with coding this part. So yeah, this is your ESP32, and we are going to be including the Wi-Fi library. So that's called as Wi-Fi.h. So we'll start. Hashtag include Wi-Fi.h. Careful about the caps, people. F is in caps. So Wi-Fi.h. This is the library which you guys are going to be using. And with that, we'll come to the void setup. These are like the initiations part which you're going to be doing. And I'm going to initiate a serial monitor. So I'm going to use serial.begin of the baud rate. I'll keep it as 9600 itself, the most common thing. And I'll just print, serial.print ln of, connecting to this walkie thing or Wi-Fi. Let's say connecting to Wi-Fi. Connecting to Wi-Fi. So thing is, actually, if you're having your own board and you're programming it, right, you'll be able to connect it to your own hotspot. But now that is not kind of possible, but there is a virtual hotspot which everybody will be able to use. It's there presented by Walkthrough. So let's call that name as, it's called as Walkthrough guest. Walkthrough T-U-S-T. That's called as Walkthrough guest. And it doesn't have a password. So that's just an empty string. And we'll go to, let's connect it now. So Wi-Fi dot begin of name, comma, password. So you guys don't need to specify some channel. It's kind of optional. But here I'm giving a channel. This is the channel in which communication is going to be done. And why is this channel given? Is that, no noise or some kind of, disturbances are going to creep into it. And with that, we're done with that part. And now we'll just, connect it. So while Wi-Fi, so there is this command called Wi-Fi.status off. And it will, show the status if it's connected or not. So this is, let's say if it is not connected. If it is connected, then this is going to display some constant called Wi-Fi connected, inbuilt constant. You guys don't need to worry about the name and all. This is some inbuilt constant which is presented by this protocol itself. And we'll delay it by say 100 seconds. You don't want it each second, right? You don't want the status each second. Till then it will have to print a dot. Let's say that's what you are going to do. Print of a dot. Right, and with that will come out of this loop. And once it's printed, you guys can just display this message connected. So println, what it does, it just prints it in the new line. Connected. So yeah, that's done. Don't forget the semicolon, otherwise you're going to get a lot of errors. And if I want to know the address to which this is connected, that also you guys will be able to see. There is this function called Wi-Fi.local IP. So let's do that. Serial.print of, let's say, address. ln of Wi-Fi dot local IP. This is the function which is there. And with that, the void setup is done. I'm actually not going to include anything in the void loop. If you guys are interested, you guys can go connect it to some website. All of that is still left to you guys. And let me leave it empty, it's fine. So hope all of this is clear. I'll just run through the code once more. So Wi-Fi.h is the protocol which you guys are using to connect the ESP to the internet. And in the void setup, I first initialized the serial monitor and I'm displaying this, statement connecting to Wi-Fi. And there is this virtual hotspot called Walkway Guest, which doesn't have a password. And it is connected via channel 6. This is optional, but if you're giving this, it's kind of enhancing your quality of connection. That's all it's giving. And Wi-Fi.begin does that. And Wi-Fi.statusof is a function which is used to check the connectivity status. If it returns a constant called WL connected, it means it is connected to the Wi-Fi, otherwise no. So that's why I've just written a small loop. You'll just know, when it gets connected. You just don't want to be left, not knowing when it's connected and all. That's why I'm just printing this dot at an interval of 100 milliseconds. And once it's connected, it's going to be displaying this connected message. And if you want to know the address to which it is connected, you can use this function Wi-Fi.localIP. And yeah, that's basically it. We'll start the simulation, but if you guys have any doubt in the code, you guys can, just put it in the Q&A. Just a second, checking for doubts. Oh, what is 6 is basically the channel number in which the communication is occurring. Can you please repeat? Bhavesh, I think I've repeated. Are you clear right now? Is it fine, or do you want me to repeat once more? Jawahar has a doubt. 1 minute, I'll just unmute him. Yeah.
Right to type include Wi-Fi, it directly change to Wi-Fi Nina.
Oh yeah, that's another thing
Hello?
which is present. Yeah, I'm able to hear you.
Yeah, that is
That
fine.
is,
Right?
Sorry?
That is fine, right? Wi-Fi NINE.
Well, Wi-Fi.h itself is doing that, so I don't think that is required. This is the
I
basic
tried-
communication. Okay. Is it working with that? Then I think it should be fine.
I haven't finished it yet, but when I type Wi-Fi.h, it automatically changes it to Wi-Fi NINE.h.
Change it back to Wi-Fi.h. I'll tell you if that Wi-Fi Nina will work or not.
Okay.
Yeah. So any other doubts, people? Anything else? Any clarifications? Yeah. Oh, you want me to repeat the whole code once more, is it? Pari? One minute. There are people with doubts. Sarah. Okay, I've enabled your mic, Sarah. What is the doubt which you're facing? Is there any doubt?
Hello.
Yeah, hello.
Ma'am, when we are using a void loop, do we have to put some delay in it?
Oh, it's not necessary. You can just leave it.
Okay.
Like here, we are actually not running anything on loop, right? So it's empty. If you want, you can put anything there, like some delay or some statement.
It says that that will speed up the simulation.
Sorry?
It says that if we add some delay, that will speed up the simulation.
No, that's fine. This is not going to take any time and you won't be able to speed it up either. Like only if it gets connected, that's when we'll get it. Like we wanted to connect it to Wi-Fi. That's it. That's all this code is going to do. So I don't think you'll have to write anything in the void loop here.
Okay. Thank you.
Yeah. You're welcome. Yeah. And Amrita I've enabled your mic. What's the doubt?
Yeah, please repeat once again, ma'am.
Okay. You want me to repeat the whole code, is it?
Yes, ma'am. Yes, ma'am.
Library called Wi-Fi.h, which we are using it to connect the ESP32 to Wi-Fi. So that's what I've first imported the library here. And then in the void setup, we are connecting it to Wi-Fi. That's all we are doing. So I've initialized the serial monitor using this command serial.beginoff. And this 9600 is the baud rate. And then I'm printing, this is just a print statement which I've given inside. And if you're connecting it to Wi-Fi, you will need some, name of that Wi-Fi and the password. Here, you'll be able to only connect to the virtual hotspot, and that's called as walkwe guest. And it doesn't have a password, so that's why I've put it as an empty string. And if you see this command Wi-Fi.beginoff, it'll take in 3 arguments. Name is the name of that Wi-Fi hotspot to which you're connecting. Password is the password which you have to give. And this 6 is the channel number. It's not kind of necessary, but if you give it, it just improves, the communication. That's it. Like, less errors can creep in. That's what we mean by that. And till you're connecting it, you want something to be displayed. Like that's why I'm displaying this dot. That is a full stop. I'm displaying inside a loop. The Wi-Fi.status is the function which will tell me if the ESP is connected to the Wi-Fi or not. And if it gets connected, then that will return well connected, which is a default variable which walkwe itself gives. You don't need to worry about that. As long as it's not connected, it's going to be, printing this dot. And I've given a delay because, you'll have to wait, right? Otherwise, it's going to print a lot of dots. That's what this dot is there for. And once it is getting connected, this condition will get violated and it will come to this part where you're printing disconnected, and you'll want to find the address to which this ESP32 is getting connected. I'm just introducing this function to you guys. That's it. And that function is Wi-Fi.local IP.
Yeah, thank you, ma'am.
I'm so sorry, guys. Like, were you guys able to listen to the end? Like, did you guys understand this properly, or do you want me to repeat once more? I'm sorry for the network issue. Is it clear? So can we simulate this and see? Okay, so there are no doubts apparently. So I'll go simulate this guy. Shouldn't the dot be in quotation? 1 minute in the while loop. Oh, this dot you mean, is it? Yeah, it should be. Thank you. It's a string, great. Yeah, thank you. C++ code should be not specify data type. Wait a minute, 1 minute. Oh yeah, sorry. Cat name. Let's call this cat password. I hope this runs. Thank you, people. And first, I think it'll give an error telling that this library doesn't exist. We'll install it and then we'll run it once more. 1 minute, guys. Just a minute. He'll avoid all this confusion. Let's put it here. I just wanted to explain it to you guys. Now that it's clear, I think this is not like. Just a minute. Is that library installed? Just a minute, people. I'll reshare this slide. There is a small issue with this. Sorry about that. I'm sorry, we'll try running it once more. And a minute, wait. While loop off, I haven't given. Okay, turn it again. Guys are taking time for compiling. Not getting compiled apparently. Just a minute, guys. We'll just try refreshing this. Oh yeah, it got connected. So yeah, that's it. So you can see the address which is displayed at the end. So this is what we want the simulation to do, and it's done. So hope there are no issues with this and it's all clear. So if that's the case, then there is a short quiz on Wi-Fi, and with that you guys are done. I'll just share that link. Hope it's visible right now. So I've attached the simulation link here. You guys can go, if you're not able to get it now, you guys can go and get it later when we share the slides with you guys. So here's the Slido page, you guys can join. Okay, so I hope everybody is joined there. Okay, so we'll continue now, guys. Come on. There are just 2 more questions left. So Wi-Fi communication occurs here. What kind of signals? So I've explained this So what are the bases of communication? Like what signals are used here? Radio, infrared, microwave, UV. 65 people answered so far. Okay, I'll give you some more time so the others can also comment. Come on, guys. So 102 people have voted and 92% says it's radio signals, which is right, it's radio signals. And we'll see the leaderboard now. Okay, we'll go to the next question, the last question for today. So a very simple thing, does Arduino Uno support Wi-Fi and Bluetooth modules? We have discussed this in the beginning also. So I think it's a very straightforward question, so you guys can easily answer. Come on, guys. No says 65% and yes says 35%. You'll have to go with the majority. The answer is no. That's why we're using ESP32, right? So yeah, let's see the final leaderboard for today. Purab tops the list, followed by Nagarjan, Ashley, Satyam Kumar, and Fanindra Kumar. Congratulations, Purab. That will come his presentation. Do you have anything to add, Ishwar?
And hello people, and we'll float a Google form in the Q&A section, and it will be open for 10 minutes, 10 to 15 minutes, and fill it for attendance. Yeah, I hope you can see the Google form. Is it clear for all of you? No, the attendance will not be shared in the WhatsApp group. It will be only in the Teams, and it will be only for 10 minutes. It will be open. You have to post. You have to fill it before that. Like if you have filled the attendance form, then it is fine. You can leave. I'll again post the attendance form. Again, the attendance form is in the Q&A section, not in the chat box.
Good afternoon, sir. Am I audible?